Hi students, the topic of today's interest is the chemical preservation of food. Food is something quite indispensable of man's life, but yet it has been found to be perishable. And at the times of scarcity of food, we cannot let the food to be spoiled or to be decayed. And hence we use various chemicals which could help us to preserve the food. And today we're going to talk about those chemical preservatives. The term preservative refers to the functional name of a wide variety of compounds that will help us to slow or to prevent the bacterial growth in a wide range of products like foods, medicines, personal care products, etc. And they not only retard the microbial growth, but they could also inhibit, retard, or arrest any process which will cause the decomposition of food. Usually, they have been added at small quantities, about 0.02%, and they do not alter the organoleptic and the physicochemical properties of food. These preservatives, they usually interfere with the cell membranes of the organisms, their enzymatic activity, and also their genetic mechanism. Sometimes these preservatives, when they are applied to the food, they act as directive editors, or probably they are being developed by themselves during the process of, such as in the case of fermentation. So all the components which will prevent the spoilage of food due to the presence of their chemical nature, all these components which are chemically by nature and which will preserve the food from spoilage are referred to as the chemical preservatives. Now, the FSSAI has divided these preservatives mainly into class 1 and class 2 preservatives. Class 1 preservatives, they are generally found in the common kitchen and they include the natural counterparts of salt, sugar, then you have vinegar, then you also have vegetable oil, honey, wood smoke, as well as the natural elements. All the natural elements that which we use for food preservation come under the class 1 preservatives. Whereas the class 2 preservatives, they are usually man-made or unnatural. They are usually chemically synthesized and they include sorbates, sulfates, benzoates, etc. Since the class 1 preservatives are natural in nature, there is no much limit in the usage of class 1 unless and until they have been specified. Whereas in the case of class 2 preservatives, there are always a limit up to which a class 2 preservative can be used in the food. Then, while as we had mentioned earlier, these have been found to be class 1 preservatives have been found to be natural, and hence you need not to be cautious while we are using it. But there is some risk mainly involved when we are using the class 2 preservatives, as these are all chemicals. So let's go into the details of which are the different chemical preservatives. And you should always remember that as we had mentioned earlier, food spoilage depends upon extrinsic and intrinsic factors, as well as the microbial factors which will contribute to the spoilage. The chemical preservation would also depend upon the intrinsic factors of the food as well as the extrinsic factors, the microbial levels as well as the processing factors. The intrinsic factors include the food nutrients, the food composition, the pH or the acidity, the buffering capacity of the food, the oxidation reduction potential as well as its water activity. And the extrinsic factors which will influence the action of the chemical preservative include the processing temperature, the atmosphere, and the relative humidity. In addition to this, you can see that various microbial factors also influence the action of chemical preservatives. It could be like the inherent resistance. Now, sometimes you might have vegetative cells, sometimes you might have spore cells, and spore cells have been found to be more resistant to damage or to killing than a vegetative cell. Then, of course, strain-based differences to chemical action is also be there in different microbes. Then the microbial load which could be present in the food is also a factor which will influence the action of the chemical preservative. If you have a less microbial load at the very beginning, the chemical preservative can act at a very faster rate. Then the growth rate of the organism, the interaction with other microbes. That's another factor sometimes. The interaction with the other microbes would help the organism to gain over the preservative. The cellular composition, whether it is gram positive or gram negative, the cellular status of the microbe, that is the microbe in the food injured or not? Now, when you, what is it, after freezing the food, suddenly when you thaw it, that will cause an injury to the microbes which are also being present in the food. Then ability to form biofilms. These are all factors. If there's a lots of biofilm in the food, what happens? The action to which, the level to which a chemical preservative can act will be found to be less. So, the microbial factors greatly influence the level to which a chemical preservative can act on in the food. We can see that various processing conditions, that is changes in the food composition, changes in the microbial populations, as well as changes in the food microstructure, can be brought about by various processing strategies adopted in the food. And all this changes, that is either the change in the food composition, the change in the microbial population, as well as change in the food microstructure, would greatly influence the action of the chemical preservatives. So, in a whole, we have to say that all these factors, that is the intrinsic, extrinsic, microbial, as well as the factors which are being formed as a result of the food processing, will also influence the effectiveness of a chemical preservative, let it be a class 1 or a class 2 preservative. We'll be talking about the details of the different types of preservatives in the coming session. Thank you for right now.